is about Wi-Fi. If you're having any Wi-Fi connection issues or aren't able to connect, please go to the registration desk and they will be able to give you a Wi-Fi password. So if you have any questions about Wi-Fi, the registration desk is just right there at the entrance. So with that, let me introduce you to our moderator, David Bainbridge.
Hi, as he says, my name is David Bainbridge, and never really been called someone who moderates anything, or moderator general. Anyway, so a couple other announcements. Most importantly, if we have a subject that we look like we're digging in real deep and need further conversation, there are sessions tomorrow that we will put that off to or continue it in. So if there's something that goes really deep, and I say time cut off, we'll just move it up over there in the parking lot. Let me go through and introduce the TST here. Over on the far right, we have Patrick Liu from Huawei. Patrick currently is the ONS community brigade leader for the dynamic configuration. That's the Yang netcom port that Thomas talked about earlier. This project does provide model-driven capabilities into ONOS. He also is the team lead in Huawei America, which leads the integration for open source software with ONOS. Next to him, in the leader, we have Brian O'Connor. He works at ON.Labs. I guess we call it ONF now officially. That's how it goes. He, like all the people for ON.Labs, are a little bit of everything and have their hands in everything. My first introduction to Brian was really around the intent framework, and so I'll call him the grandfather of that. In the center of the seat, we have Thomas Wachuska. Hopefully I said that correctly. Also from ON.Labs, and he is, I guess, technical lead architect as well as TST. That's currently going. So he is another man of all talents. And next to him, we have John Hart, and another ON.Lab person that has his hands in everything. And finally, Ali Shabibi. What? Al Shabibi? I missed it out. Sorry. He's just someone who's a pain in my side and also has his hands in everything. As a way to kick off the question, so start your juices flowing and think of questions as we go forward. In one sentence or less, if each of you could kind of express your biggest challenge and opportunity for ONOS in the next coming year, or in one sentence or less, and start at the far side with Patrick.
Okay. Hello. Thank you, moderators, to introduce myself to the audience here. Regarding the opportunities, I think as communities provide great opportunities for the multi-vendor environments. So take a look at what we did in IP plus optical, multi-vendors and multi-layers in the ONS year 2016. So and also the multi-vendor engaged ACTN is incoming in IETF for 97, which is all the partners include the Ciena, Fujitsu's, Huawei, Ericsson, SKT. All these are members in the ONOS and partners in the ONOS. So I think that's a great opportunity to provide such multi-vendors environment. Okay, the challenge part. The challenge part is, my background is in, I work for the vendors, build the legacy box for the 20 years. So that is okay. Now is when we migrate from the legacy system to this new environment, new architectures. So you see a lot of challenges. The big challenge is okay. So the knowledge you have to extend your knowledge, and you have to learn a lot of the programming language and the tools. Yeah, that is not the biggest one. So the biggest one to me, I think, is a mindset change. Now, the example is that in the legacy systems, build your box is focused on the 5 nines or even more. But over here, so we're thinking, take a look at a lot of people talk about the fail fast. So the fail fast, that is a different way to build your systems. Another challenge our thinking is take a look at the 5 nines in the legacy systems. But now all the equipment is the 3 nines or something, even less than that. how to use the 3.9 equipment and way use a software to build your system to reach the carrier grade. We're talking about the carrier grade. What that means, how to build that, that is pretty challenging work to me. I was thinking, especially for me, many years in the legacy and the vendors to build the current network and move to this new environment, new architectures. It's pretty challenging.
Thank you, Patrick. Okay, Brian?
Thanks. So I think for me, the challenge and opportunity is around applications. We've built a platform. We always talked about ONOS as a platform, an operating system. And so making sure that we have the abstractions right so that code can be onboarded and that it can sit safely and isolated from others. I think to keep it brief and we can get into this more, I think making sure that the platform supports all the code that's coming in from elsewhere as applications, that it's easy to write applications and that applications can be a way to extend the platform going forward.
All right, thank you. Thomas?
The biggest challenge, I think, is to effectively harness the power of the community. I mean, there's a lot of exuberance, and so I'd like to sort of see it move forward some of the key initiatives that I've talked about earlier in the morning.
Thank you, John.
Yeah, I think one of the biggest challenges is getting ONOS deployed in more places, especially with service providers. There's a huge opportunity because there's so many different service providers that are interested in various applications of ONOS and deploying these. But there's some other challenges. So Thomas mentioned one of them earlier in his talk, the ISSU. There's a lot of work that needs to be done around monitoring and management of the system and debugging the system when things go wrong. So yeah, there's plenty of work to be done around taking ONOS into operating OS.
So I get to go last, so they cover everything and I have to find something else. I think what's going to be challenging for ONOS going forward is to refrain from wanting to build yet another NMS that does everything under the sun in a networking world. And we should really focus on control and let management off to someone else. So that's going to be the challenge going forward. I think avoid putting too much code in the same code base and separating things out a bit better, and having clear architecture and a simpler architecture.
Okay, thank you guys. Now we'll open the questions to the floor. And if you guys don't have questions, I do have some, but I would much rather hear what you guys are thinking. So if you have a question, please raise your hand and we have a mic that will come to you. If you just want to shout the question, I'll repeat it on my.
Okay. Robin from Huawei. Yeah, I'm the architect of the Huawei controller. In fact, Huawei's controller is based on the ONOS. We have published the commercial delivery controller on the September the 1st. So during the course of the developer the Huawei commercial delivery controller, we encounter many issues that are based on the ONOS. So I wonder that why. So if I want to say so, a lot of questions for our TST members, and I just mentioned several of it. Okay, the first one is regarding the slides of the Thomas. So my suggestion is like this one, because now you know that the SDN is not the beginning, because this is a lot of use cases. So now that I think the ONOS is provide a good base for the controller develop the application. On the other hand, maybe another phase is beginning, because this is define more use cases. We use the use cases to drive the architecture enhancement. So I think that maybe later we can define some of these the useful use cases, so that I think the developers can understand why we do the architecture enhancement, why we do the young model, why we do the network virtualization enhancement, and also why we do the gRPC. So I think that's maybe my suggestion. So I think I'm sure Thomas, your opinion on this one. Okay. You say it's okay?
Thomas, if I can form that into a question, let me see if I can get this question.
Yes, I was going to ask, I missed the question mark.
Yeah. Is there a location that individuals could go to understand the current use cases that ONOS works with, and perhaps contribute to those use cases or ask questions about those use cases?
I'm actually not sure. So we have a wiki, but which is pretty good source of information. But we clearly have not the roadmap that I've talked about right now is not formulated on a wiki yet, and it will be published on a wiki and in the near future. That's something that we're sort of providing a sort of a formal narrative of some of the initiatives that I've outlined this morning. That is something that we're still working on. Not really. There's not any. But
Okay. So
I have a VP of engineering that would love to answer this question.
Okay. Yeah. Okay. Deal. Thanks. I just want to add a little bit to it in first use cases. Really important. ONOS has been built through use cases from the beginning, and in addition to the wiki, we're starting a blog series where some of the users of ONOS get to describe how they're using ONOS, and there is going to be some place that we have to be able to go and see reference implementations out there. And the last thing I'll say about it is we need help with it. So if you're interested in doing that, get involved.
Okay, thanks.
Okay, next question.
I just want to make sure I'm happy to answer more of your questions, particularly if no one else has questions, but I do want to kind of move it around the auditorium if there are other questions.
Okay, next one. Next one. I propose the next question.
Is there anyone else that has a question?
No.
You could even ask it in French. We've got Ali.
Hello, I'm Magdalene from OSMOS area from Paris. So I want to go back to the roadmap presented earlier by Thomas. So I didn't get the idea about the virtualization feature. So you were taking that in the future. We want that ONOS provide more network virtualization features, or maybe if I good understood your idea, so we want to replace OpenStack maybe by ONOS, or just improve the communication with OpenStack.
so just provided, I will let Ali answer any more question, but I'm just going to provide a concise one here. The idea is not to replace. I did not mean to give that impression. It was just provide an alternate mechanism, and basically provide a mechanism which is more analogous to what OVX provided, and this is where I'm going to turn it over to Ali to explain more what that is.
So thanks, Thomas. So usually when you use, say, OpenStack to deploy your computer environment, you also get networking with it, and the networking is rather complicated. Here what we're doing is we're taking the networking aspect out. We still use Neutron, and we create virtual networks. Now we create these virtual networks that are controlled by ONOS. And the feature of these virtual networks is they are also programmable. So if you want to be able to program your virtual network just like you program your physical network, you can. Okay, that's the general idea. That's what OpenVertex does. OpenVertex is a proof of concept. Bringing it into ONOS is making it a real use case.
Okay, thank you.
And let me also add that this has applications in many different areas. For example, it can be something that can be used as a mechanism for virtualizing access to your, providing virtual view of your own network to your peers in context of federation. It can also be used in context of providing access to one's own network to potentially to partners or to sort of collaborators, but you only want to give them certain slice or a view of a network. So it has applications in many different areas.
Thank you. Another question.
Yes, I have Dominique Vercher from the TST Labs, France. I have a question on the roadmap of ONOS, especially concerning the peer-to-peer approach that has been talked before. And I would like to understand which level of peer-to-peer connectivity you want to provide. Will it be very close to the system level, resource interface, or maybe on a higher level with a service interface, and how you are going to define, in fact, this level of peer-to-peer protocol, probably that you are probably a project thinking, envisioning to propose.
I mean,
I hope it was clear.
no, that was perfectly fine. The question, I just wanted to make sure that
Yeah.
I wasn't speaking.
I mean, I think there's a couple of different approaches to how to tackle peer-to-peer. One way is you could treat peer-to-peer like you treat any tenant of a virtual network. So you could say, I want to provide a virtual slice. That virtual slice is going to provide virtual resources and potentially a service interface like an intent programming interface. I think that's probably a good place to start. We've also, I think, seen an implementation through the Icona project. There's also been others that have talked about using gRPC to expose devices and some degree of flow programming in a peer-to-peer way. So there have been a lot of different approaches that have been proposed. Ultimately, though, I think my personal opinion is that treating it just like a virtual network tenant would enable peers or potentially nodes in a hierarchy to have an abstracted view of the resources, links, topology, and then also a higher level programming interface.
Anyone else have a comment on that? No? All right. Next question then.
Thank you.
Maybe I can also explain the Icona project. We are working on the Icona project. So basically, we are providing a way to clusterize your network, both in a single domain, but also in multi-domain. So we are trying to expose topology and abstracted view of the topology between all the clusters. And what we are trying to allow is that Icona will be able to expose the abstracted view as you want. So basically, you can expose the view with a single big switch of your network to other remote cluster, or even a full mesh of your topology. Or we are working on, let's say, giving the possibility to control your network via policy and to expose your network to different peering or external domain using this policy and such a way. So also, Icona is a southbound application, so it's a provider basically, and it is configurable via normal ONOS TFG commands. And also, it is not meant to use a single protocol to share your network. You can plug your own protocol, your own implementation. We are currently working on REST, but we will move to gRPC and also the protocol. These are our approaches that we are working on.
So I think I see a theme coming here that there needs to be a better way of information dissemination out to the community to find out about these projects. And I know we have the wiki, but that also needs a better way to find out within the wiki where to go and who to contact for further information.
Yes, and then this is something that we know we actually, it's sort of a deficit that we have. And actually, we're very happy to have a new member at ON.Lab, she's in Chao, sitting in the audience, and she's going to help us sort of, get better organized, and using her sort of technical expertise, but also sort of organizational skills to help us assemble all of this information in a more accessible and more visible way, so that, again, towards the goal of harnessing the power of the community. I'm going to return back to the subject of the hierarchy goal. Just a quick addition here. There's another project called ACTN, which is essentially trying to accomplish federation, which is governed by through a standard IETF model to basically facilitate traffic engineering interactions between the different domains. And this is more in a hierarchical context rather than a peering context, but it's a similar sort of project.
Okay. This is another view from the community and actually from Huawei. And I would like to show this question to Ali. Okay. So, okay. I'm not very sure I got you just now. At the beginning, you talk about the challenge, but I think when we talk about controller and NMS, normally it's very struggling. Also, when we discuss the internet, because people is used to be a little bit confused by those terminology called configuration topology, because it's all seems quite familiar to the traditional NMS world. So how I'd like to get you more elaborate and opinion. What do you think of how the controller seems to be differentiated with NMS? How that in the future trend, how the NMS will evaluate, how the controller will evaluate. That they will coexist or one of them will disappear. I'd like to get you more opinion.
So I think I mean they'll coexist because you need something that can exercise a control function on the data plane to achieve whatever the NMS or whatever management function you have. That will observe the network. That will be passed actually back to a control function that will enforce whatever needs to be enforced. So it's like now, essentially, you have in your legacy devices, you have a control plane that's running the software, and your NMS observes the network and tries to adjust and optimize the traffic pattern, traffic allocations. It's the same thing here. And the tendency of controllers, if you look at other controllers in the industry, is to throw everything inside the same controller. So whether it's statistics collection, alarm collection, accounting, security functions, all inside the same controller. And a lot of people think that's okay. But if you actually think about it, that just means that you have a code base that is completely bloated and does everything. Right? We know from good software engineering and software design that trying to build software that does everything under the sun just doesn't work. Right? These are like magical unicorn softwares that don't exist. Right? It's if you build something for a specific function, then you can build around it for other things. It doesn't mean that you don't use that particular thing, but it's good at doing one thing and it does it very well. That's all I care about.
And just a little bit of editorializing here. I agree with you, Ellie. And I think part of the problem we see in the development around controllers is you already have that information because you're communicating to the devices. And with the traditional NMS systems, you don't have that information. You're going off to a remote control plane to get the information. And the tendency, because I already have the information in software, I can start just implementing those features right there. So I think that line of delineation between control and management is critical. And I think it is a very blurred line in terms of what people do today. Is where do you see that line? Like John, I'm gonna put you on the spot because you haven't talked yet. Where do you see that line of delineation between control and network management?
I guess when you're thinking about sort of the future-looking networks that ONOS is kind of targeting mostly, the control is kind of the flow programming, right? The programming of the calling of the data packets to the network. Management would be the statistics, the collection, the analysis, and all that kind of stuff, the policy perhaps, for the calculation of policy. Yeah, so for me, that's what I would say.
Okay. Just continuing this thread, I love power. Brian, and I'll go down the line. And I'll skip Thomas for reasons because I've had this discussion with him before. When you talk about management control, particularly in traditional, you have multiple processes involved. The control plane is separate from the management plane. In ONOS, as in any controller piece of software, there's a danger or a risk that these get mixed, as already pointed to. So as we see ONOS today and its functions, how do you see us splitting out even some of the functions that exist today into a more microservice, I'll use the buzzword, microservice environment, so that we have these very clear delineated processes in terms of management control, as well as, I think Thomas mentioned in his talk, the ability to pull out applications into other places, right? And they have interoperability.
Yeah, so I think from my perspective, It's one of the things that we've kind of blurred is even within the control functionality, we've bundled a lot of that into the ONOS platform. We have applications that'll do L2 switching. We have applications that'll do L3 routing. We have applications that'll enforce arbitrary policy. And I think what is important is to draw boundaries around the platform, the core. This is the store, the messaging, routing, high availability, persistence, etc. To layer on top a few key abstractions, some around visibility, so to be able to retrieve information from the network, see what's there, some around programming, this is the classic SDN control, and some around some degree of box configuration. And then provide clean APIs, which will still allow side loading of applications like a kernel mod, but also have high performance, high speed, more fully functional APIs that will stream this data out to other processes and other places. And so I think having abstractions for building applications is going to be key. It's going to mean pulling some of the stuff that's currently in ONOS out a little bit. I think it will also mean bulking up some of the APIs around configuration, because some configuration is part of control, some configuration is part of management. We're already starting to see some external APIs, some gRPC, Kafka, RabbitMQ, so both RPC APIs and event streaming APIs out of the platform to enable the offloading of some of the number crunching, accounting, etc. But I guess to your original question, what's going to be important here is to provide some clarity to what's part of core platform, what's part of core networking, and make it clear that this boundary between programming, config, and visibility is a clean line. Some apps will be included, and some apps can do this remotely.
Thanks. And actually, we continue this, we're going to bring Patrick in here as lead of the Yang work here, and I think I want to hear Thomas's opinion on this afterwards, because I think that's going to be very interesting as well. With the introduction of the Yang models into ONOS, we have the concept that almost any model can now become part of ONOS, and that means almost any model becomes part of the API into ONOS. This is a risk because it can pollute the unified model that everybody talks to, and have clients of ONOS now having to have intimate knowledge of a vendor model, which really brings us back to where we are in network management today. So how within the Yang project itself do you see this happening or evolving so that we don't have just a plethora of unrelated models, essentially vendor APIs, popular? So Patrick, I'd love to hear your response as kind of the lead of that project, and Thomas, if you could chime in as well, that'd be great.
Yeah. Actually, it's a challenging questions. Now, so there is asked things like we have northbound, we have multiple service models, right? On the southbound, we have IETF standard model. It's the standard model from the different standard organizations, and also the different vendors that might use the different models, device model. So how to do that is it's a challenge work. You can let's take a look at the southbound first. So you can build the drivers for each the device. Every single time when you add the new device, you can build the drivers to do the code changes as currently we are doing on the legacy on the current box. So another way is basically you can build the common drivers and just use the device model driven architectures. Every single time when you change your model, you don't have to change the code. So to change the model, you inject the model into the ONOS, and they will do some kind of translations to handle that. So the similar mechanism on the northbound. So similar things, you can do the similar and do the surface level translation. Basically, that is in the network level, and yeah, so the similar mechanism. So in summaries, basically the requirements over here, we were trying to focus on build the mechanism, which is the service independent architectures to handle the service specific model to handle that. So It's from the northbound and the southbound.
Thank you, Thomas. Do you have
Can I jump in? Yeah. So I guess one of the things, to answer your question, yes, by allowing arbitrary models in from the southbound or arbitrary models in for services, you do potentially complicate and maybe, from a purist standpoint, pollute the ONOS API. But on both the configuration and the programming front, we've seen that as you raise the level of abstraction, you typically give up a little bit of flexibility. And so there are certain use cases, certain people, I like to think of them as the 1% use cases. For other people, they're larger percentages, but where you have that switch on a device or where you have that special rule that needs to go into a special flow table with certain parameters, that the higher level of abstraction, you don't really want to have to accommodate. And so both on the control side and on the config side, the ability to introduce new models and have those knobs available at the top level means that the program can do anything that devices can do. Now, from the perspective of writing applications, it means your applications are going to be locked into your environment. It means they're not going to be portable, not going to be flexible. And so from an application writer, if you don't need that lower level of abstraction, use the highest level of abstraction that achieves your objective. And I guess going forward, when some of these smaller knobs, extraneous features need to work their way in, we can either find ways to absorb the differences through a mechanism we call drivers. So certain devices always have this certain pattern. This driver knows how to do the transformation. Now you can use the higher level of abstraction. Or as more and more vendors take on these new types of configuration, in ONOS we call these behaviors. They can be codified, not necessarily through a standard, but through open source software. More and more people can adapt to them, and then they become part of a more narrow, higher level API. And so I think a good way of thinking of it is we want the platform to be fully general. So someone could write a specific application for a specific vendor's firmware's box and make it work. But that's going to be a case that, maybe you do it for demo, proof of concept, or because you happen to have this box sitting over there you need to work with. Going forward, the idea though is to raise the level of abstraction, improve the API through iteration, and then work with a larger community to basically make the API standard by the types of functionality people are looking for.
So what Brian said, just going to add to it. Also another form of sort of consolidating on the same view of the world is use of standards. Like, of course, there's plenty to choose from, like IETF or OpenConfig. But clearly, we can also allow the models to converge onto the standard. Now, of course, that's much slower process. Some might say glacier, but it's still one that we could still rely on. But clearly, we can't be beholden to it, which is why we also need to have other mechanisms to be able to converge on sort of the same view. Because if you really think about it, a single model is an embodiment of an abstraction. So if you allow two models, you have two abstractions and so forth. And so if you allow all models, there's no abstraction, which clearly has its allure, because you can do anything. But then you take on, by doing that, you take on the responsibility of managing the differences and right. And so somewhere else has to lie the reconciliation point for dealing with different use of devices. And some service providers have already some other place where they can rely on dealing with it, and it's perfectly fine. So they can use ONOS in that context, and we certainly want to enable that. But we also understand the abstractions are important, and this is where I would start repeating what Brian says. So I'll stop.
All right, thank you. All right, any questions from the audience at this point?
Hi, my name is Freeman. I came from Huawei. We came out to performance. So some guy told us ONOS performance is better than ODR because the network subsystem is in the platform. But Thomas told us you will separate the platform and the core subsystem. So my question is, does brings any performance impact more better or bad?
When I said perhaps I wasn't because the talk was of high level nature, I didn't get into low detail, so perhaps that didn't come across. It's really just a code separation, code base separation. In terms of deployment and runtime, they're gonna still continue to run the same process. So at runtime, the difference between the two is between what we have now and after we separate the core from the platform will be indistinguishable because packaging will remain the same.
Okay.
Thank you. Any other questions from the audience?
In the back, that way.
Hi, my name is Kalyan. My question is with respect to current network management. If you look at it, most of the network management in current scenario is more of reactive management rather than the predictive management. But looking at the way the innovations and many things happening in the SDN controller side, okay, so we can have big data and other things. We can build statistical model and apply the machine learning and predict what can happen to the network, okay, and what can probable potential risk to the network. And I can make proactive network management to prevent all those things. So I want to know from ONOS side, is there any roadmap to build such things in the ONOS controller?
I think I'll leave with skeleton.
No, not yet. Again, that's something else. So this is a good example of where you have a system that can learn about the network and inform the control part. Right? Just keep those two things separate. Right? They don't need to run the same process. Right? I don't need to have a whole machine learning engine running in the ONOS process. It should be next door. So I think what you're suggesting is very valuable, and obviously identifying traffic patterns, especially for service provider networks, which have very clear patterns. You know, it's a very diurnal pattern. That's totally valuable. But again, it's a question of like putting it in the right place.
That also implies that ONOS will be able to deliver that information both for real-time big data analysis, streaming, if you will, as well as latent analysis over time periods. Anybody have any thoughts on how that's going to be accomplished in terms of communications, dealing with that type of bandwidth of data being passed back and forth?
So the philosophy of ONOS thus far could be summarized as follows. It's mostly concerned with here and now. It's just a brief history of time in the back and just a little bit of future, but not much. So it's kind of a little bit like Zen. It's just here and now. And so if you want to push off any sort of more predictive functionality, we would follow the same strategy as Ali suggested. And to answer your question in terms of how to deal with sort of potentially streaming of large amounts of data to such off platforms knowledge bases, I honestly don't have an answer, but it doesn't necessarily need to come through ONOS. And I think this is what Ali's point was earlier. In case of, for example, there is a project for the network telemetry that's associated with P4, something that more intelligence on devices can enable. And so this is something we definitely want to keep an eye on. And again, this could be an example where the devices could be programmed, whether through ONOS or through some other means, to be able to report telemetric data to some other basically off-platform data sinks, which are better equipped to deal with those scales. And then you accumulate information and use some other off-platform application to be able to provide that predictive capability. And then use ONOS as a means to deploy the policies.
That is interesting because I think it brings us into the concept. I'm going to ping John here because we've talked in a while that while ONOS will be a source of some data for this off-box analysis, it may just be that data might be coming from devices directly, which means you're going to have multiple connections to the devices. How is that going to work out? And some devices have connection limitations. Are we going to start putting too much load? I mean, comment on some of that stuff.
Yeah, I guess that's more of a question of device design, right? If you need to get this data on the device, then the device needs to be able to somehow support that. So nowadays we have interfaces for doing it. They don't have to be the best interfaces like SNMP and other things. But yeah, it's up to the device to be able to export that data fast enough to the various management systems that they're going to be wanting to use it.
So you jump at the mic, Brian.
Oh, I guess the reason I did this is because you don't necessarily have to go to the device to get the information. And so the telemetry stuff that Thomas was alluding to, you could potentially tag traffic or create, little postcards and send those to a collector. So you could, if you have your time series databases or event streaming databases, you could just have the devices in certain circumstances redirect traffic in that direction. And so the controller's responsibility there is to ensure that the rules are set up, the policy's there, and the collector's, somewhere in the network, and then that information can flow there. And we have an example of this, not for telemetry, but for dealing with BGP sessions. We currently, don't pull those through the control channel because of limitations, and et cetera. That gets redirected to a collector that sits in the network, makes decisions about how routes need to move, and then that informs ONOS with the updates of policy. And so I think back to your original question, this is something we think would be, or at least I think would be interesting to be part of the ecosystem to sort of iterate what Elise said, but it's not the job of a controller, or it's not the job of ONOS to do this. Just the job of ONOS to make sure the data is available so that you can do your analysis, and that we have a sufficiently rich policy API so that you can inform ONOS with the decisions that your machine learning is making.
So can I just add one thing? So as networking people, we have this tendency to always want to reinvent solutions to problems that have already been solved in other fields very well. So if you look at how network devices, and especially white boxes, are evolving, and the software you run on these white boxes, more and more these switches just look like computers with a lot of ports, right? That's the only real difference that they have. It's just a bunch of ports that are ASIC controlled rather than being system controlled. So if you look at the computing world, we've solved all these problems. How do we extract metrics? How do we extract telemetry? We've got a bunch of tools. We've got, I don't know, cacti and forget that one name, whatever. There's a whole bunch of stuff to extract information from a device and expose it to the world through message buses, through event mechanisms. Why do we not reuse these things rather than reinvent some solution that's specific to networking? It doesn't make sense. We don't need to do this. The people who've done it, who've thought about it, who've built entire frameworks around that, we should be focused on reusing those as opposed to reinventing our own. I think that's the higher message when we move towards SDN and open boxes that we can actually run our own software on and install Linux on it and run the same packages that we run on our computers. We can run those on our switches as well.
I want to add something. So from the system point of view, so you see we have the controllers. Basically, we have an analytical platform, and the policies platform, and the orchestrators. So here we are built the closed loop, so that when you get the notifications from the network and go through the agents, you don't have to build everything in your controllers. From this perspective, I completely agree with what Brent said. Another thing is you can go through the analytical platform to collect all these information. The key point here is in this such a large closed loop, you will see when you want to give the quick response to some network event or the alert, right? So its latency could be longer. So here is a trade-off we have to do in the futures. So which part need to be built into the controller, and which part need to be built through this large closed loop. So I think here have to know clear the approach and the clear ideas of how to build that. I are thinking that in the futures, the ONOS platform can think about these ones to leverage the low latencies and the boundaries between the collected stats between the controller and the network device.
Thank you. Got about 6 minutes left, so questions. I think I saw the hand way in the back there first.
It's actually not really a question, it's just kind of validate what you were saying. So to do with telemetry is, I know, as you say, people want to reconnect with the network device, but the reality is we're already seeing telemetry platforms moving away from that. If you look at the content service providers, Amazon, Google, people who are hyperscale, and I think that's really, when you think about data center, you know, we kind of think about building it as a service provider, but actually we really need to look at the hyperscale guys because they've already solved all these problems. So the streaming telemetry piece is kind of, there's two parts to it. One is if you can make enhancements on the physical platform, because it is, you know, a more modern platform, you're already seeing this. People are down to the line card in terms of how they stream telemetry out of it. And they're putting it straight into acquisition platforms. Those are then policy controlled and just delivered either to a controller, to machine learning. There's a number of benefits in this. It stops the Linux box under the desk network management platform problems. You take someone like AT&T, they have over 200 or 300 platforms trying to hold every device on the network. So we've already busted that step, and it doesn't make sense to enhance those devices to code 300 or 400 of those. It makes sense to consolidate. So I think I just wanted to add kind of a bit of perspective from my previous career on that. So thank you for that. Sorry, Andrew McLaughlin, speaking as an individual, cut off from Huawei.
Thank you. Anyone, next question. Making you get your exercise today, David.
Hello, sir. So I have a simple question to be honest. So you're talking about the types operations of NMS, telling that we just monitor the network elements or from a traffic perspective and not providing any solution. It's not part of ONOS. So in that case, so this quality of service part of ONOS with respect to preventing traffic outages or reducing fixed costs. How is it? How are you relating the ONOS design with respect to the like customer network? When you want to implement ONOS on a live network, and you're telling that you want to integrate ONOS with NMS. And now NMS is doing a traditional thing that we have caps operations, port monitoring, configuration, all this stuff. But now, what value in that case ONOS will add to the existing NMS to make it distinguishable? ONOS is providing a value back on target, yes. That's what. So what is that cap point? I'm looking for that cap point which distinguishes ONOS from other solutions. So, like as one of my colleagues suggested, like proactiveness. To look at a bigger picture, proactiveness can be shown as artificial intelligence in current industry, like whatever solutions you're providing, you're just creating software, and instead of a human being doing the work, you're creating an artificial thing. So can we relate AI with the existing infrastructure, collaborating with and providing a better solution? Like how is it? I just want to understand.
So I'm trying to boil that down to a simple question.
So maybe I can reframe the question to what pieces in ONOS could help provide QoS so that when you have a proactive AI solution, you can ensure certain guarantees for your customers' traffic. And so in ONOS, we've got on the flow programming side, we've got the group subsystem and meter subsystem, which would enable you to do some degree of bandwidth enforcement on a per flow basis. We've got a resource reservation service, which permits the allocation of bandwidth on certain ports on certain links. And then we've also got a notion of a bandwidth constraint in the intent framework, not yet enforced in the data plane, but that's actually some active work going on through the deployment brigade. From a configuration perspective, to do bandwidth enforcement, you want to be able to set up queues with certain minimum max rates, a certain priority. That would typically be done over configuration. In ONOS today, it could be done manually over OBSDB or netcom. And with the introduction of the dynamic config models that dynamic config brigade is working on, we'll probably have a number of models that would enable you to do that. So from the perspective of QoS, there are a lot of different primitives in ONOS, depending upon whether you want to restrict the rate of traffic through meters. You can do fast failover or load balancing using groups. You can do resource reservation via the core subsystem, and then enforcement via queues or the configuration of queues using config.
Okay, so there's nothing to do with like how it's not a preventive measure, but it's just to like reshape the whole technology or the resources, whatever we have, and that's what we're doing.
So when you say not a preventive measure, I mean you could set up queues with min rates. You can configure those queues to have various latency properties or prioritization properties. You could gate the way traffic goes into those queues. And then if there were failures to occur in the network, you could, in hardware, fail over to existing ports where you could also have reservations made. But maybe that's not your question.
Yes, because in few months back, I read one article regarding HBO channel. It was on article that not able to broadcast through those through HBO whatever traffic they have. So it costs some revenue loss. So not about the revenue loss, but with respect to the quality, like will owners be able to address such problems which are actually causing traffic impacting operators? So because tomorrow if you are looking at the market due to IoT needs, there is a lot of traffic pumping into the equipment and even 100 gig switches will not be sufficient in the long run considering the traffic flow. So in that case, how will owners be able to help us? Is owners having the picture of okay, next tomorrow IoT is coming? Are we ready for the challenge? So is the plan going in that direction? I just want to understand in which direction owners is taking that.
So Brian, is this something that needs to be taken offline, a little more deeper discussion? I don't mean to cut it off, but they're kind of at the time limit, or is this something that can be answered quickly?
I mean, I think there's a lot of depth to your question. The short answer is that ONOS is working on building mechanisms to do both multipath and provide path protection and enforcement. How you choose to use those primitives is sort of up to an application. And so some of the applications and use cases you've talked about are not maybe in scope at the moment, but there's certainly opportunity to work on them on top of the primitives we're trying to build into the platform.
Certainly there's more questions that people have. Is there an email list that they can ask these questions on that can get to the TSC so that they can be asked offline or answered offline, as well as I know we have some sessions tomorrow to work on this?
Yes, does everyone have their pen out? It's called ONOS-TST.
Okay.
And ONOSproject.org. So it should be very straightforward.
And again, as Thomas mentioned in his talk, show up for TSC meetings. It's always fun to interrupt there and get in trouble on those as well. So I'd like to thank the panelists and for the questions from the audience. Thank you very much.
Thank you, TST and David. And we're here for another day and a half, so please feel free to grab anybody you see up on stage and ask them the questions you have. And apologies that we've run out of time now, but I do want to share some information about what's coming up for the rest of the day. So I think something very exciting is coming up next, lunch being one of those things. But as well as there's space for lunch back there, right in the entrance, but at the same time, we're giving you the opportunity to meet with and interact people from the ONOS community who are sharing their projects with you. So we're calling it the Science Fair. So please grab your lunch and then go and see the different demos that are out there. There's 10 different tables set up with different community members, and we'll do this again tomorrow with a different set of people, but I think this will be a really interesting opportunity to see what people are doing with ONOS and SDN. So please take advantage of that. And then just one logistics question. So far the day has been here in this auditorium, but after the Science Fair and after lunch at 2 p.m. we transition to a different building. So just to avoid any confusion, all the tracks this afternoon will be in building 44. If you come out of the auditorium, it will be, I believe, that way. There'll be signs, but look for building 44 and go up one flight of stairs. And there'll be 3 rooms there, 1 for each track. So just a quick reminder, there are 3 tracks this afternoon. One where you'll be able to learn more about ONOS itself. We're calling ONOS Basics. That's an opportunity to learn more about ONOS, level up your understanding and experience with that. There'll be a range of tracks for there. Another one will be a hackathon. As a reminder, Ali is running a hackathon. There'll be a prize for the team that makes them, we'll do a voting tomorrow, and you'll be able to help us award a prize to the team that made the most interesting hack over the event. And then lastly, we're also, the other track is a community showcase. Very similar to the science fair, we've invited people from the community to come and present what they're doing. And I think that will be very interesting as well. So all those 3 tracks, again, starting at 2 o'clock, will be in Building 44, not here. We'll meet again here tomorrow morning. But that's what's happening this afternoon. Again, sorry that we had to cut off your questions, but please feel free to grab TST members and ask them during lunch or during the tracks later this afternoon. So please help yourself to the lunch and take a look at the science fair. Thank you.